Partial fractions with the repeated denominators is what we are going to cover in this lesson. Please don't forget to subscribe to the channel. Now, denominators with repeated factors. Repeated means something is repeating itself, or we have same factors. So this one, x plus 4 power 2 is the same as x plus 4, x plus 4. So now that one, don't treat it as linear, because this one is linear, the factor is linear, but is repeating 2 times. So how do we handle them? You first check, is it linear? Yes. So we have seen how we treat it as a linear factor. But now this time it's repeating 2 times. We said if it's linear, the numerator is always a powerless, which is going to be a constant. So how we do these ones is, you start with power 1 up to when you reach to this power it has there. So now, you see that the whole of this is squared. So we say, we let this be, now this one is linear, a over x minus 2, then plus. This one now, we go to the smallest power, to power 1. So it's going to be now b over x plus 4, then plus c over x plus 4, now the whole square. So, we start with the power of this bracket, then up to reach the power on this bracket. In that one, we shall reach up to power 3. But with this one is linear, then this one, we start with the power 1, get b, then this one, the power is linear, but we put it to power c because of that idea. Now here, the LCM is that this one is contained in here. The LCM for this and this is this. So it means that we are just getting the LCM of the whole thing. We shall get the LCM between this and this in simple terms. Then this and with this. So the LCM is going to be this like this. So now this one I have equaling 2. Now the LCM for the whole of this is going to be a into. Now this goes in here. So that this, when we divide it here, we are going to make this as x plus 4 the whole square. Then plus b into. This, when we divide it here, it's going to cancel one of the brackets. You have now x minus 4. Then plus c. When you get this, you divide it here because this is the LCM. You divide it here, and be made with x minus 2. The whole over the LCM x plus 4 the whole square. And you say that this is cancelling with this. So you have now simple as that. Now we say, if you want to get this, you equate now the factor which is not here. So this factor is not here, so you equate this to 0, so that we can get this. So you say, when x minus 2 is equal to 0. When you make now, to eliminate this, you have to make this bracket 0, and this one is 0, so that you have only one unknown. So that because we can easily solve one equation, one equation with one unknown. So when you solve this, that our x is going to be at 2. So when you put in a place of x, when you put it 2, you have 6 into 2 equaling to a into 2 plus 4, the whole square. Then this is going to be 0. And I put here 2. 2 minus 2 is 0. So the whole of this is 0. 2 minus 2 is also 0. So from here, so that I have 12 equaling to, this is going to be 6 squared, 36a. So when I write it here, my a becomes 5. As simple as that. Now, to eliminate, now this is plus. To eliminate now of this, if I want to eliminate one of this, so if I want to get this, I equate which is the bracket which is not here to 0. So this bracket is not here, so I equate x plus 4 to 0. So now, my x plus 4 is 0, so that my x is going to be negative 4. So when I put here negative 4 now, the whole of this will be 0, so I'll be adding 6 into negative 4 equaling to, now this is going to be 0, This is going to be 0. So here I'm going to be having c into negative 4 minus 2. This is going to give me, this one is giving me negative 24. Sorry, this one is giving me negative 24. This side is this, equaling to, when I get this, I get negative 6 c. And start dividing here, start minus c is going to be 4. So I have A, I have C. I need now B. Now to get B is very easy. You get the smallest number and you reduce these ones. So instead the smallest I can get 0 and I put here 0, it will work. I can get a 1 and I put here 1, it will work. Anything. As long as you get the second equation. So now here you just choose any you want to get. So, but you choose always a smallest figure, as smallest integer. So instead I am going to use, always make sure you use these ones too. So let me call it when x is 1. When x is 1, it's going to work for me. When x is 1, here I have 6 equaling 2. This is going to be 1 plus 4, which is 5. So I'm going to be having 25. Then plus 1 minus 2, that's negative 1 plus this, that is 5. 5 times negative 1, I have negative 5b. Then plus this c, it is going to give me 1 minus 2, it's going to give me a negative c. Now we have everything here. It's that we have our m, our s here. We need our B, we have our C there. So if we substitute, you see that I want now to get B example. So my 5B is going to be, I take everything the other side. So this one I take it this side, I take this side. So I have 25 into a third, the value of A. Then minus C, which is 4 from here. Then this 6 minus 6. And you see from there, this one is going to give me minus 24. First of all, this one is going to give me 25. 5b is going to be, when you simplify this, you get 25 over 3 minus, when you simplify this, you get 10. And see, when you do that with your calculator, you see this one is going to be 30, so negative 5. This one is going to give you negative 30 plus 25, that would be negative 5. Divided by this is that our b is going to be negative 5. You simplify there. Now, you have the value of b also, you have A, you have also C. Now you come back and you write this. So from there, so now our 6 x over into x plus 4. The whole square is going to give you our A, which is our third, over x minus 2 plus our B, which is negative a third, over x plus 4 plus our C, which is 4 over x plus 4, the whole square. So I have to write this as a fraction, they get this, then this times this. So you cannot write this here, you cannot write this there, that is also okay. When you come to this, it's that you first take, first of all, is it proper? Why I'm not taking? Because I'm seeing this proper. Because this one is power 1, this one is here, the degree is going to be 3. So the degree, the denominator is greater, so that one is proper. So that this one, the degree of the whole function here, this one, this is going to be the highest degree as 3. So this one is 3, here this one is 2. So it's proper. If it's proper, you just do it the way it is. This one is repeated, this one is linear. Why? Because that now this one, the whole of it is having a square on it. That's why it said it's repeated. So now, the whole of this is going to be now over. It's going to be identically equaling to A over X. Now you lower the power to the smallest as 1, then plus B when you reach the highest, which is as here. Then plus the C over, so this one is linear, x minus 1, as simple as that. So So it's the LCM, this one, the LCM, this is in here. So the LCM is going to be this times this, which is already here. So now we have, and you see that the LCM is going to cancel in the last step, in the next step. That's why I'm writing this equaling 2. Now we say this goes here. So we get this divided here, remain with a into x minus 1 into xy. Because when you get this divided here, 1x is going to cancel and remain with 1 with that. Then plus b. When you get this divided here, get x minus 1. Then plus c. When you get this divided here, get x squared. So that's how we handle that. The denominator, the LCM is this, and it's that, like in this step, it's cancelled in orange. So to eliminate this, so that I can just eliminate this and this. So by saying when x is 0. When x is 0, then I want to get the value of b. So here I'm going to be adding 0. So here I'm going to be adding 0. So this one I'm having negative 3 equaling 2. The whole of this 0 times this is 0. So here I'm having b into negative 1. Then this is going to be 0. And start from here. My b is a 3. To get the other, now to get c, I start this c. The bracket is not here, is this. So I equate now this to 0. So when my x is, when you equate this to 0, you just put this but opposite in sign. So when x is 1, that's what we've been doing by now. When x is 1, I want to get 1 minus 1 to go to 0. Or so when x minus 1 is 0, and then you make x the sum. So when x is 1, here I'm having 1 minus 3, that's negative 2, minus, so here I'm having negative 4. Because this is going to give me negative 2 minus 3, that's negative 5 plus 1, that's negative 4. So when I put here 1, this will be 0. When I put here 1, here this will be 0. So I'll be adding c into 1 squared. That's what my c is going to be at negative 4. Now the rest is just choose any. We have used the 0, you have used the 1 now. So that I want to make it smaller. So if I put here 2, it's going to be minus 1, which will give me 1, which will be a good value. So when x is 2, you can also choose a 3. But because I see 2 minus 1 will give me 1, which is a smaller value. That's why I'm choosing 2. So I'm having 2 minus 3, that's negative 1. 2 squared, I'm having 4. And it's negative 2, that's negative 8. And this negative 1 to get negative 9 equaling 2. When I put here 2, I have a 2 minus 1, I have 1 into 2, then plus b into 2 minus 1, which is 1, then plus c into 2 squared. So instead I want a. So negative 9 is going to be, my a here I have 3. This is going to be 3a, 2a. So this is going to be 2a. 2a. So here I'm having this times this 2. So I have 2a. My b here is 3. So plus 3. Because b is 3. Then c is negative 4 times this 4. We get negative 16. Next, this will be negative 13. This will be negative 13. When you take it this side, you have now negative 9 plus 13 equaling to 2a. When you simplify this, is that you're having a 4. So our 4 is equaling to 2a, which implies that our a is going to be 2. As simple as that. Now, after doing that, we come and write this x minus 3 minus 2x squared over. Instead, in an end equal to a, our a is 2 over x, plus b, our b is 3 over x squared, plus c, our c is negative 4 over x minus 1. Or you can write this as negative and make this positive. It's up to you, and that will be our solution. You always write this final step when you don't have unknowns. When you simplify this, I'm sure you'll get back this. When I get this, I'm going to just write how we are processing it, and then you find answers yourselves. So this one is going to be now, is first of all, it's proper. Because you see this one is power 1, and this one, you see this one is, the height is going to be x3. X power 3 times x, you get x power 4. And see this one is, the whole of it is to degree 4. Then this one is 6 to degree 3. Still this one, the power here is greater than the power there, so that it is proper. So we say, we get over is going to be equal to a over x plus 3. Now plus. So this one is power 3. I start with the one power 1. So b over x minus 1 plus c over x. I increase now to power 2. Then plus until when I reach this one. So d over x minus 1 power 3. Then you simplify that. So the LCM is going to be the same as here. So now this is going to be x cubed minus 10x squared plus 26x plus 3 equaling 2. This goes here, and I get this divided here. I have a into this is the only thing surviving cubed plus. And I get this, and I divide it here. This is going to answer in one bracket, so I'll be having b into this. But this one is going to cancel in 1, so that I have x minus 1 squared plus. And I get this, divide it here, there is c. This will survive. But this is going, because this is power 2, it's going to cancel with 2 over this, and remain with only 1. Then plus d. I get this d, and I divide it here. This so that the whole of this is going to cancel this, and remain with x plus 3. And I think you can complete. That's it, members. I wish you well.